who weren't here today. All right, well, thanks everyone for joining. It's my great pleasure to introduce today's speaker, Farnaz Behram, who is a PhD candidate at Georgia Tech. And Farnaz has done a lot of great work in the field of software testing and analysis. It's also close to my research area, so I'm also very excited for this talk. Her research has been recognized multiple times. She has 2 ACM 6 Distinguished Paper Awards, and I think 2 other papers are also nominees or runners up for the Distinguished Paper Award. In addition to all that, she also has an upcoming paper at ASC this year, which I just saw on the accepted papers list about random test input generation in Android. So I'm really excited to read that paper as well. It's also close to my research here. So yeah, I'm looking forward to your talk, and thanks a lot for agreeing to give talk, Farnaz. Over to you.
Okay, cool. Thanks for the introduction, Rohan. So hi, everyone. Thank you so much for joining my talk today. So in today's talk, I'm going to talk about some of the work that I've done during my PhD, which focuses on leveraging existing software artifacts to support design, development, and testing of mobile applications. As you all know, the market behind mobile applications is massive. There are 5.5 million mobile applications that are available in the market. And these mobile applications generate a $1.3 trillion economy. There are 4.5 billion users that are using these mobile applications every day. And on average, each user spends about 2 hours using these mobile applications, which means roughly about 1 month per year. And of course, all of this is possible because there are millions of developers out there that are creating these mobile applications every day. Developing mobile applications, like any other kind of software, is costly. So the overarching goal of my research is to leverage existing software artifacts to reduce the software development cost. By what I mean by software artifacts here is any useful information that is produced by developers during the software development process. So as an example, you can think of source code, test cases, execution logs, code reviews, and so on, any type of software artifact. Well, I'm not the first one who thought about this, and in fact, it has been more than a decade that researchers have been mining online software repositories to take advantage of existing software artifacts, mostly source code, to provide automated support for different activities, like bug prediction or refactorings or automatically updating the API. But if you look at these techniques, they are mostly focused on supporting the implementation and maintenance activities. And they ignore all other very important software engineering tasks that account for a large portion of the software development process. So in my work, I try to leverage the existing software artifacts to provide automated support for additional tasks that have been mostly ignored by previous work. So in this particular talk, I'm going to focus on 2 of these other very important software engineering tasks, which are software design and testing. So in the first part of the talk, I'm going to present GUI fetch, a code search technique that takes advantage of the growing number of open source apps in the public repositories to support the design and development of the app. And in the second part of the talk, I'm going to talk about another technique, App Test Migrator, which takes advantage of existing test cases to support the testing of mobile applications. So let's first start with GUI fetch. A typical way to design and develop mobile applications is to go from the sketches of the apps to the actual app. So the process starts first by sketching the GUIs of the applications, which involves defining layouts, choosing widgets, and then configuring and connecting the screen. Then the process continues by creating the actual GUIs from these sketches, and then implementing the logic behind the GUIs and link them to the high-level GUIs. So the technique I'm going to talk about today focuses on the first part of this process, which goes from the sketching GUIs to the creating actual GUIs. So let me illustrate how this would work at high level using an example. So let's imagine that an UX designer draws a sketch of an expense tracking application. So here is the first screen that shows the total expenses for this month, and it has two buttons, view expenses and add new expense. If the user selects the add new expense button, the second screen opens up, which allows the user to enter the details of the expense. And clicking on either cancel or save will take the user back to the first screen. Now, let's assume that the UX designer uses a sketching tool to draw the sketch of the app that I just showed you. Now, what are the challenges? If we want to find an actual GUI for the app that I just showed you in the public open source repository. First of all, creating the model of these app GUIs is particularly challenging because there is not just a single way to create these GUIs. So users can take advantage of the XML layout files, or they can create these GUIs programmatically, or they can use combination of both. Here, we are also interested in modeling the transitions that are happening between the screens in addition to the screens themselves. And in order to be able to compare these sketches with these actual apps, we need to come up with an effective similarity metric. Now, let me tell you how GUI fetch works at high level. So given the sketch that the user draw and a set of keywords, GUI fetch first searches the public repositories to find a set of potential applications. It then analyzes these applications and the sketch that the user draw and builds a model for both the sketch and these applications. It then uses these models to compute a similarity metric and then uses the metric to rank this potential application. And as output, it will provide the ranking of the app to the users, which contains both the screenshot of the app and their source code, corresponding source code. For example, here, the screenshot of the app that the tool returns when we provide the sketch that I just showed you. So now let me tell you what are the scenarios of usage for GUI fetch. First of all, GUI fetch allows the UX designers to explore the state of the art of an app domain. So seeing a GUI that is similar in spread, but slightly different from what they had in mind may provide them new ideas so they can go back and refine their sketches. We also know that creating GUIs often happens as part of an iterative development process, in that GUIs are often and constantly get changed. So in this context, GUI fetch can support early prototyping. So the developers can get a GUI of the app that is close to what they had in mind, then they can possibly modify it and then use it as an initial throwaway prototype. And in cases where the quality of the code that is returned by the tool meets the expectation of the developers, then the developers can use that code as a starting point to build their own application. Now, let's take a look at each of these steps in more detail. So the search process here starts with a set of keywords that the user provides, and GUI fetch performs two separate searches. So first, it checks for the source files that contains these keywords, plus the Android term, and also the manifest files that is in the source code. Then it selects those projects that correspond to these files, which the tool is able to successfully compile them. But since it's very likely for the code that we retrieve from the open source public repositories to contain some identical or very similar application, then it leverages code similarity detection techniques to identify these similar applications and remove them, so it can get a set of unique apps. So far, GUI fetch found these unique applications. Now it's time to build a model for both the sketch that the user provided and these unique applications.
Can I ask a question about the search? So you said you search based on the keywords. Are they provided by the user, or can you infer keywords from a hand-drawn sketch?
No, we get that as like a text input.
Okay, are you using the hand-drawn sketch at all, or are you just using the keywords?
So it's just both of them are the input. So basically both the keywords and the sketch that the user provides.
Okay, do you do some kind of like image comparison then based on the hand-drawn sketch and the potential apps?
Yeah, so I'm going to get there in a second, but
Oh,
what
okay.
happens here is, so basically the first set of the apps that we find is based on the keywords, and then to validate them, we use the sketch that the user provides. So
Oh,
basically,
okay.
it's just a sort of like a two steps process.
Okay, thank you.
So yeah, so once we find, the GUI fetch finds these unique apps based on the keywords that the user provides, now we want to build a model for the sketch that the user provided. So here, GUI fetch uses a sketch parser, which generates the model, the screens of the app as a set of the sketch GUI hierarchies. So remember that these sketch GUI hierarchies are going to eventually be used to compare to actual Android GUI hierarchies. That means that we need to create a mapping between the sketch elements and actual Android widgets. And depending on the sketching tool that is used, this can be done differently. For example, if the sketches are conceptual drawings or they are screenshots, then OCR and computer vision techniques are often used to identify these sketch elements and create the mapping. Or if the sketches are like SVG-based sketches, some heuristics are often used. And there are some other sketching tools out there that allow you to directly parse the output of the application. So depending on the sketching tool that is used, this mapping is created, and the sketch parser also extracts the attributes that are corresponding to these widgets, like type, height, text, and so on. And as I mentioned earlier, we are also interested in creating a model for the transition that are happening between the screens. So the sketch parser creates this sketch transition graph that extracts the transition between the screens, where in this graph, the nodes represent the screens and the edges represent the widgets that are causing the transitions in the sketch. So now that we also
I have a question
build them
about the sketch parser, if I can ask. Yeah, so I was wondering, so do you construct, so have you created the sketch parsers yourself, or are you using sort of off-the-shelf tools that can do this sort of extraction of the hierarchy from a sketch?
So I created this sketch parser for the one of the sketching tools that is out there, and which we are able to directly parse the output of the sketch. But there are some, I mean, if you want to use another tool for the implementation, then you can plug in other, techniques that are used. But we implemented the sketch parser also for the tool that we picked for the implementation.
I see. So the user has to also make the sketch in a particular tool where they have so that it looks that the sketch is in a format that you can easily parse.
Right, exactly. So it's just a sketching tool is called Pencil, and then we just parse the output of that. Yeah.
Okay, nice. Thanks.
Okay, now it's time for the GUI fetch to build a model for this unique application that is found in the public open source repository. So to build the model for the apps, it creates this the GUI hierarchies for every possible screen of the application. And to do that, it first dynamically crawls the application. So this means that it launches the app and generates the GUI events in the user interface of the application, as many as possible. And whenever it reaches a screen, then it computes the GUI hierarchy for that screen dynamically. But since it's very likely for the dynamic crawler not to be able to reach to all the screens of the application, then GUI fetch uses a static analyzer to statically compute the GUI hierarchies for those screens that the dynamic crawler was not able to reach to them. And the reason that we use the dynamic crawler first and then the static analyzer is that it's very common for these GUIs, at least parts of them, to be built dynamically. So the GUI hierarchy that you can compute dynamically is often more precise than the static one. And what I mean by precise in this context is that the statically computed GUI hierarchy might contain more or less GUI elements compared to the dynamically computed GUI hierarchy. So once it has computed these GUI hierarchies, it merges them and then uses them as a set of app GUI hierarchies. And as I mentioned earlier, we are also interested in modeling the transition between the screens as well. So both this dynamic crawler and static analyzer also keeps track of the transitions that are happening between the screen, and it represents these transitions as an app transition graph. So now that we have the model for both the Sketch and these applications that is found in the open source public repositories, it's time to compute the similarity metric between them. So the goal here would be to compute the overall similarity score between each app considered and the user provided Sketch. So the first part of this overall similarity score is the screen similarity score. So to compute that, GUI-Fetch first pre-process the text that are associated with this widget. And what I mean by pre-processing here is, for example, it does some lemmatization, then uses a part of a speech tagger to ignore irrelevant part of the text like pronoun, conjunction, and so on. And once it does that, it compares this pre-processed text using the 11-inch time distance. It then normalizes the other attributes like size and position, and then compare these normalized numbers as well, and then uses the results as to match the widgets with the highest score from the Sketch to this application. And then it uses these matched widgets to compute the screen similarity scores. And finally, based on those, it maps the Sketch screens to the app screens accordingly. So now that GUI-Fetch computed these screen similarity scores and created this mapping, it computes the second part of this overall similarity score, which is transition similarity score. So given the mapping, the Sketch transition graph and the app transition graph, it checks for every transition in the Sketch transition graph, whether such a transition exists in the app transition graph, and if so, it computes the similarity between the widgets that are causing the transitions in both of these graphs. And based on that, it computes this transition similarity score. So finally, GUI-Fetch adds these numbers up and then uses them to rank the apps and provide the ranking to the users. And as I mentioned earlier, this ranking contains both the screenshots and the actual screens, the source code of the application, so that users can just scan these screenshots before they want to just dive into the details of the code. Now let's see how I evaluated GUI-Fetch. So I evaluated GUI-Fetch and I investigated 2 research questions. So first, I wanted to know how relevant are these GUI-Fetch recommendations for users. And I also wanted to know how well does GUI-Fetch ranking match the user ranking. So to answer these research questions, I performed a user study where I recruited 16 participants. Then I randomly selected 2 app categories, mobile banking and address book, and assigned an app category to each of these participants randomly. Then I developed this web application and asked the participants to perform a set of tasks using the tool. So first I asked them to draw a sketch for their assigned category, app category. Then I asked them to run the tool using their sketch. And then once they got these recommendations back from the tool, I asked them to classify these recommendations as either relevant or irrelevant. And finally, I asked them to rank these recommendations of the tool. Now let's take a look at the results for the first research question. So the number of screens that the user draw was per sketch was between 1 and 7. And the total number of GUI-Fetch recommendations was 138 for 35 screens, between 0 and 5 per screen. So here is the figure that shows the number of relevant and irrelevant recommendations for both address book and mobile banking categories. So the x-axis shows the screen number and the y-axis shows the frequency. So let me summarize the results for you here. So overall, participants found 81% of these 135 recommendations to be relevant. And for 19 out of 35 screens, roughly about 54% of them, participants found all of the GUI-Fetch recommendations to be relevant. Now let's take a look at the results for the second research question that focuses on comparing the GUI-Fetch and user ranking. So to answer this research question, we assess their rankings through using some rank correlation analysis, where we pick two well-known metrics in this context, which are Kendall-Tau and Spearman-Rho metrics. So this is the table that shows the result of our analysis. The first column shows the screen number. The second and third column shows the coefficient and p-values associated with Kendall-Tau metric. And the last two columns shows the Spearman-Rho coefficient and p-values. So of the 24 screens for which the tool was able to find more than one recommendation, the user and GUI fetch rankings were identical for 14 screens. They were strongly correlated for 4 screens. They were weakly correlated for 3 screens, and they were not correlated for 3 screens. So overall, the user and GUI fetch rankings were identical or strongly correlated for 75% of the screens.
How much of that correlation do you think is due to the first part of the search based on the keywords, and how much of it is due to the image similarities and then to the transition graph similarities?
So I think so for the first part that we focused on relevant and irrelevant recommendations, I think I would say that the first part, which was related to the keyword, maybe have more impact. But for the second part that we looked at the actual ranking, I think basically the analysis that we did, I think it play a more important role than just the keyword.
Okay, thanks.
So in the second part of the talk, I'm going to focus on another technique, App Test Migrator, which leverages the existing test cases to support the testing of mobile applications. So let me first start by giving you a motivating example. So let's imagine that you have 2 banking applications. One is Bank of America, and the other one is Wells Fargo app. And you want to use these 2 apps to send money to your friends. So to do that, in the Wells Fargo app, first you need to specify that you want to send money. Then you select the contact information for your friend, enter the amount that you want to transfer, review the transaction, and finally send the money. Similarly, in the Bank of America application, you select send, the contact information for your friend, you enter the amount, you continue the transaction, and you finally send the money. As you can see here, although the GUIs of these 2 applications are different, you can still map the GUI events from one application to another. And more generally, there are tons of applications out there that if you look at them more carefully, you can divide them into different categories, where the apps that belong to each category share much of their functionality. And my vision or intuition is that we can take advantage of this situation to improve the way that we test these mobile applications. So instead of creating brand new tests for each application, it would be great if we can migrate existing test cases from one application to all other similar applications, if not completely, at least partially. So the overall goal here is to migrate the test cases between apps that share at least part of their functionality. So this way, we can reuse the human intelligence that is encoded in existing test cases to generate test cases that more mimics the behavior of the actual users. And then this way, we can ultimately save a potentially considerable amount of the human effort that is involved in testing these kind of mobile applications. So besides the application of the test migration in the context of general apps that I just told you about, there is another application for test migration, which is in the context of education. So let's imagine that an instructor gives an assignment to the students of the class, which the assignment contains a specification of developing a mobile application. So the students are supposed to go and develop these mobile applications based on this specification independently. So now that the instructor wants to grade this assignment, it would be great if the instructor can write test cases just for one of these applications and then migrate them to all other apps that the student stored, because all of them are supposed to be based on the same specification. And this could be particularly useful for very large courses like online or MOOC courses. And the idea can be used for any type of GUI-based assignment. So it could be a mobile app, could be a web app, or even a desktop application. Now, what are the challenges if we want to migrate test cases from one application to another similar application? So first of all, there is not necessarily a one-to-one mapping between the steps that the users need to perform to cover specific functionality from one application to another. So for example, in one application, you might need less steps, or you might need more steps to cover the similar functionality. There might be also a semantic gap between these two apps. So let's say that in both of the apps, you can go and sign up as a new user. But what if the developer of the first app uses the word sign up and the developer of the other app uses the word register? And also, we are here interested in not only migrating the GUI events from one application to another, but also migrating the oracles. Now, let me tell you how App Test Migrator works at high level.
I have a question about the problems definition. So I was curious, what is the representation of test case? When you say test case, is it like a sequence of GUI events?
Yes, so the sequence of GUI events, which comes with an assertion that check for different properties of the GUI element. That is going to be basically the oracle or the assertion.
I see, I see. So is that something that is apparent from the like a test code, or is it something that you can get through something like record and replay? Like how do you capture a test case, for example?
So there are some tools out there that allow you to write GUI test cases.
I see.
So
okay, so you're just using models from a test generator. Okay.
Yeah, I'm gonna just go into more details of that.
Sounds good. Yeah, I'll let you do.
Okay. So now let's see how the App Test Migrator works at high level. So given a source app, a set of source tests for the source app, and a target app, App Test Migrator generate a set of test cases for the target app. So first, given these source tests, App Test Migrator instruments these source tests, so we can get a set of instrumented source tests. It then runs these instrumented sources and collects a sequence of GUI events that are triggered and assertions that are checked by the test case. And once it collects all of those information, then it continues by first migrating the GUI events, then migrating the oracles, and finally use those migrated GUI events and assertions to generate an actual tested script. Now I'm going to go into the details of each of these steps. So here the instrumenter instruments the APIs in the testing framework to collect the information about GUI interactions. But what I mean by GUI interactions here are the GUI events that are triggered and assertions that are checked by the test case. So you can think of GUI events as a set of triples that contain an action. So it could be, for example, click, long click, swipe, or any other type of action. A target for that action, which could be a button, text view, or any kind of GUI widget, and an optional input that the user might provide, for example, when filling out a form. So you can also think of assertions as a function that has a condition and a GUI element for which that condition is checked. So if that condition holds for that GUI element, then the function will return true, and if not, it will return false. So now that so far App Test Migrated collected these GUI events and assertions in the test case, now let's take a look at how the Event Migrator migrates these GUI events. So the Event Migrator consists of two major phases, the static analysis phase and the matching phase. So the static analysis phase takes as input a set of user guides for various mobile applications that contains a set of instructions that tell the users how to perform different scenarios in the app. It then uses these user guides to generate a set of numerical vectors for the vocabulary of the user guide. And these numerical vectors, roughly speaking, model the semantic similarity between the words in the user guide, which is going to be built in the context of mobile applications. So besides these word embeddings that the matching phase is going to later use them, a static analysis phase also analyzes the source code of the target app to generate a window transition graph for the target app. So this window transition graph is basically the control flow of the application, where the nodes represent different windows in the app. So the windows are basically the activities, the menus, the dialogues, the fragments, and so on in the Android application. And the transitions in the graph are the widgets that are causing the transition between these windows, which are basically the callbacks that are getting executed in the UI thread of the application. So now that the static analysis phase generated these two models, it just provides them as an input to the next phase, which is the matching phase, along with the target app, the source app, and the sequence of events that it wants to migrate. So this matching phase works in three different ways. First, there is the dynamic matcher that tries to find a match for the GUI events that the event migrator wants to migrate in the current GUI state. And to find that match, it compares the GUI element in the current GUI state with that GUI event using the word embedding that the static analysis phase generated earlier. So if it's able to find a match that way, then it will add that to the list of migrated GUI events. But if not, then the static matcher comes in, which takes advantage of this window transition graph that event migrator generated earlier to compute a potential match in the other state of the GUI. So basically, it compares the GUI event that you want to migrate to GUI events in other state of the application. And if it's able to find such a match, then it computes the shortest path from the current GUI state to the GUI state where that match exists. And if it's able to find that, then it will continue the search. But if not, then it uses a guided random selector to select a GUI event in the current GUI state randomly, but while it also takes into account the history of the previously selected GUI event. And if the matching phase reaches this point and basically the predefined time threshold has already passed and it was not able to find any matches, then it uses backtracking to invalidate the last match and then continues the search from there. But if not, meaning that it was able to find a match, then it triggers that GUI event and then continues the search. And it continues doing so until all the GUI events in the sequence are processed. So now that the app test migrator migrated these GUI events, it's time that it migrates the oracles in the test case. So before I start telling you about how Oracle Migrator works, I want to give you tell you a little bit about how these GUI oracles look like in practice. So we studied the GUI test cases that developers have written in the open source public repositories, and specifically the oracles that comes with these test cases. And we identified some common categories of these GUI oracles. So one of the most commonly used GUI oracles are the property-based GUI oracles. So these GUI oracles checks whether a GUI element in a particular GUI state has some property associated with them. So for example, they check whether the GUI element in this GUI state has some text associated with it, or whether this GUI element in this state is clickable or not, or is it displayed or not. So it could be any kind of property for that GUI element. Another category of these GUI oracles are hierarchy-based GUI oracles, where they check the relationship between the GUI elements. So for example, they check whether two GUI elements are siblings of each other, or one GUI element is the child or parent of another GUI element. And there was another type of these GUI oracles that are also focusing on checking whether the GUI element in a particular GUI set exists or not. So now that you have a better idea of this, how these GUI oracles look like in practice, let me tell you how the Oracle Migrator works. So the Oracle Migrator has 3 main steps. The first step, which is the event triggerer, triggers the migrated GUI events that the event migrator migrated in the previous step. So the target app can reach the screen that the Oracle Migrator can migrate the Oracle there. So the main step here is the matcher, which matches the elements and conditions from the source app to the target app. So basically, if you remember, I mentioned earlier that each GUI oracle consists of a condition and a GUI element for which that condition is checked. So the matcher here is responsible to find these elements and conditions from the source app to the target app, and to find out, depending on the categories of GUI oracles, it does it like a little bit different, but mostly it leverages the dynamic matchers that I told you about in the previous step. And finally, there is this Oracle generator that generates this actual oracle from these migrated GUI oracles or assertions. So you can see how the source code for these GUI oracles look like if you look at the output of the third box, which is the Oracle generator. Now that App Test Migrator also migrated the oracles, now the test generator has everything it needs to generate the actual test script for the target app. So it uses these migrated GUI events and assertions and generates these target tests, which is going to be the output of the tool. Now, let me tell you how I evaluated App Test Migrator. So I investigated 2 research questions here that focuses on the accuracy of App Test Migrator in both migrating the events and oracles from the source app to the target app. So as I mentioned earlier, one of the applications of the test migration is in the context of education. So first, I evaluated the technique in this context. So I selected 3 sets of apps that were developed by students of a software engineering course during different semesters, 3 different semesters. And I randomly picked 18 source apps from these sets of apps and 125 target applications. And the source apps already came with 63 source tests. And then I ran the GUI App Test Migrator using these source app and source tests and also the target app. So let's take a look at the results for the first research question, which focuses on the accuracy of the GUI event. So here's the figure that shows the percentage of the fully migrated, partially migrated, and not migrated test cases. But what I mean here by fully, partially, and not migrated test cases. So the fully migrated test cases are those test cases that all the GUI events that existed in the source app and had a counterpart in the target app were successfully migrated by the tool. By partially migrated, I mean at least one GUI event that existed in the source app, which had a counterpart in the target app, was successfully migrated by the tool. And by not migrated, I mean none of the GUI events were migrated by the tool. We also looked at results from another perspective, which was looking at the individual GUI events. So you can see here the percentage of the true positives, true negatives, false positives, and also false negatives. But what I mean by these metrics in the context of test migration. So true positives are those GUI events that existed in the source app, had a counterpart in the target app, and the tool was able to successfully migrate them. By true negatives, I mean those GUI events that existed in the source app, but did not have a counterpart in the target app, so the tool did not migrate them either. And by false negatives, I mean those GUI events that existed in the source app, had a counterpart in the target app, but the tool was not able to migrate them. And finally, by false positive, I mean just those incorrectly matched GUI events from the source app to the target app. So we also looked at the, evaluated the app test migrator in the context of general application. So here is the 4 app categories that we looked at, which are expense tracking, note-taking, shopping lists, and weather apps. So let me first tell you how we selected these app categories. So we looked at the app categories in a Google Play Store such that there were at least 4 apps in that category. The number of installs for those apps was more than 1,000, and the source code was available as well, which this is sort of the limitation that comes from their implementation of the tool. Then we excluded this excessively broad categories like the gaming application. Then we randomly selected the 4 app categories there, and then we selected 4 apps with the most test cases for each of these categories. And here you can see the name of these applications, the lines of code for these apps, the number of installs, the number of test cases, the number of events, the number of oracles, and the coverage for the test cases. And then we use these source apps, target apps, and the source test to basically run the app test migrator. And for a source app and target app, each time we considered 1 application in each category as a source app and all other applications as target app. And we did that for all the apps in that category. Now let's take a look at the results for the context of general apps. So here's the result for the first research question that shows the percentage of the fully migrated, partially migrated, and not migrated test cases. And here also shows the percentage of the true positive, true negative, false positive, and false negative for the individual GUI events. And for the context of general application, we also looked at the accuracy of the oracles, which you can see here, the percentage of the metrics as well. So let me summarize the results for you here in the context of general application. So App Test Migrator was able to fully migrate 48% of the test cases, partially migrate 34% of the test cases, and it was also able to fully migrate the Oracle for 42% of the fully migrated test cases. Okay, so ultimately, this idea of test migration can support the idea of test store that can be run in parallel with traditional app store. So the users can submit their apps to the test store. The test store can analyze their application, look for similar apps, then migrate the test cases from these similar applications to these new applications that were submitted to the test store, and then return these successfully migrated test cases to the user. So in today's talk, I talked about 2 techniques, GUI fetch and app test migrator, which they leverage existing software artifacts to provide automated support for design, development, and testing of mobile applications. This concludes my talk, and I would be happy to take questions.
You're muted, Rohan.
Oh, is it? Sorry, thanks, Caroline. And thanks, Farnaz, for that great talk. The results are pretty impressive. It's really cool how many apps you could migrate. Does anyone have questions?
So one thing I'm wondering about is how similar do you think the apps need to be in order for the migrator to work at all? Like, could you, like, do you think that apps, like, even in different categories could have some similarities that could allow you to migrate some tests? And this could, you could kind of look at all apps in order to try to generate kind of somewhat relevant tests to some arbitrary app.
Yeah, sure. So I think that's definitely some sort of like a next step that, so if you, for example, think of like logging to the app, right? So the logging could be like something that's shared, or like, for example, when you delete something in the list or you modify something in the list, these are like something that could be shared across apps as well, but yeah, I think in this work we looked mostly on the ones that belong to the same category, but I think that's definitely, there are some functionalities that could be shared between even the apps that do not necessarily belong to the same category.
Cool.
How critical is the GUI comparison in this app test migrator? Do you have a feel for whether you could do something similar for software that doesn't have a GUI? I'm just this sounds really useful to be able to say, here are some tests that work for this kind of type of software. Now try and migrate them over to something else. But I've got no idea how you'd approach that.
Yeah, I think it would be honestly harder for other type of test cases beyond the GUI test cases, because if you think of GUIs, there are sort of like intermediate sort of representation that have some structures, and these structures are common across the apps. I mean, they are different, but there are some percentage of the similarity between them. So I think that makes it much easier for these GUI-based applications, but at the same time harder for in the other context. But I mean, that's definitely something I haven't explored and could be looked at for other people. But yeah, I think that's there is something about these the GUIs, the representation of the GUIs that make it possible for the GUI-based app.
Okay. Also, you might have said this and I might have missed it. Did you, when you were migrating the tests, find any bugs in any of the apps that you were migrating the tests to?
So yeah, so we sort of, when I was doing the migrations, I saw some bugs here and there, but the reason that we didn't really focus the evaluation of the technique on the bug fixing, because that's some metric that goes beyond just the evaluation of the technique itself, because it depends on for example, the quality of the test cases, right? So it's not just about the migration, it also depends on the quality of the test cases. So let's say that, so you have some test cases that are, you design them to cover some specific functionality, and you want to migrate them from one application to another. And then if you look at those, I mean, just let's say you measure the coverage for that, and it's only cover 1%, but that's something that a specific scenario that you care about. So I think the test migration is going to be more useful in those contexts, that you have some specific functionality and you want to make sure that you cover those in the other apps. So that's definitely something as a side effect, that you want to discover bugs, but we didn't really focus on that during the evaluation, because there was you had to do a box seeding, which is really, I mean, something tough for the mobile applications. And so that's sort of depending on the quality of the test cases more than the technique itself.
Okay, thanks.
Sure.
Yeah, so I have a comment on the difference, or the advantage of doing this on GUIs as opposed to on general software. So one thing I really like about this technique, and I don't know whether you've tried using it for this context, but the cool thing about GUIs and capturing tests as GUI events is that that's something that is it's potentially possible to capture from just a user. So even if you didn't really have tests for a given app that somebody has written as a developer, let's say if I give a new banking app to a user, right, a user who has a bank account. If you've used banking apps before, you sort of know what the banking app should do, right? You sort of know what buttons you should click, and what screen you should sort of transition to. Because of this notion of intuition, right? We as humans, we expect apps to have sort of similar UI layouts. We expect some sort of a notion of what a transaction is, what it means to check balance, and so on and so forth. So given that you can capture tests as GUI events, and given that you can use that to test multiple apps, maybe you could even use some of the core technology that you've developed to actually automatically synthesize tests from users who are just using apps, right? So for example, if I just download an app, even if it doesn't have any tests, you're just having users actually use an app. Users are one of the best test oracles you have today, at least in mobile apps. They're way better. They're way better at reporting faults in apps than automated software testing techniques. So I don't know if you've thought about this at all, about trying to capture tests from end users, but I think some of the core concepts that you develop may be useful as building blocks to trying to do that.
Okay, so do you mean the user, so the execution logs of the user, right?
Right.
Okay, yeah, actually that's a follow-up work. I mean, it's not published yet, but so basically we looked at like execution logs that, let's say like some ordinary users just use the app and you collect the execution logs, and then you sort of use those execution logs to improve the way that you test like other applications, but in the same category.
Mm-hmm. Right. Yeah, that's pretty cool. Also, another question that I have is, since you described two different projects, right? So one where you could use sketches to identify similarity of apps, and the other one where you could sort of migrate tests across similar apps. So have you tried sort of a combination of these two things where you could potentially take an app which has tests, and then take a screenshots, use GUI sketch to find similar apps, and then migrate your test to a similar app that should actually have sort of the same logic?
So yeah, I think that's sort of close to the idea of the tester store that I mentioned, because in the tester store, when you submit the apps to the tester store, then you first need to look for the similar ones, right?
Can you still hear me? I think I lost my audio.
Oh, okay. Sorry. Can you hear me?
Sorry. Yes. Okay. Yeah. Sorry.
Oh, okay.
Right.
So yeah, so this is like similar to the tester store things, because when the developer submit the app to the tester store, first you need to look for similar apps and then migrate them. So yeah, I mean, that's something that's definitely, that's something relevant. I mean, I haven't done it myself, but yeah, that's something that can be done definitely.
Pretty cool. Thanks.
Sure.
Just a question I had. This is sort of a follow-up to Rohan's previous comment that like about synthesizing test cases from by observing user activities on other apps. So I was just wondering, like I've heard about this called random GUI testing for Android apps, where it just like randomly clicks events and tries to see if the app crashes or not. If instead of like synthesizing concrete test cases, maybe just if there are apps in the similar categories and based on the execution logs from the user, if you could bias the random testing in some way that is like informed by similar apps, and that could just lead to like, I don't know, just a better exploration of the app itself. I don't know if like this is something.
Right. Okay. Yeah. That's definitely that's actually something that we did in the follow-up work. So basically, for the execution logs that we collected from the users that were using the app, then we use those to guide the random test generator, basically.
Excellent. Thanks.
Are there any other questions? Okay, well, I think we can call it a day then. Thank you again, Farnaz, for the great talk. I guess I'll stop recording now.
Okay, cool.